Core Pew Mathematics 2, Paper 2, Further Mathematics, Advanced Level, Thursday, 6 June 2019. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. The total mark for this paper is 75 marks. Paper 2, Core Pew Mathematics 2. Question 1. Prove that tan inverse x is equals to half ln 1 plus x over 1 minus x, stating the value of the constant k. Hence, to otherwise solve the equation, 2x equals to tan bracket ln of square root of 2 minus 3x. So the first thing we would do is we would get the formula for the definition for sine x, cos x, and tan x. So tan y is sine y over cos y, and x is equals to sine y over cos y. So x is equals to e to the y minus e to the minus y over 2 divided by, because that represents sine y, divided by cos y, which is that. And we get that from that definition of cos y. So it's sine y, this one, divided by cos y. And when you divide, you change it to a times and flip the second fraction. So it becomes 2 over e to the y plus e to the minus y. The 2 will cancel. So you're left with e to the y minus e to the minus y divided by e to the y plus e to the minus y. Now you ask yourself, where do you go from here? So what you want to do is you use a mathematical technique. You multiply each of them by e to the y. So that stays the same. If everything is multiplied by the same thing, that means the expression does not change. So you just change it to another form. So you multiply each one by e to the y. You multiply e to the y times that, multiply that by e to the y, multiply that by e to the y, multiply that by e to the y. And remember, in the beginning, you had to get rid of this inverse tan there, you multiply each side by tan. So that would give you tan y equals to x. So it's very important to remember that part. So when you multiply, you would notice that e to the y times e to the y will give you e to the 2y. You add y plus y gives you 2y. E to the minus y times e to the y plus y will give minus y plus y will give you 0, and e to the 0 is 1. In the denominator, e to the y times e to the y will give you e to the 2y. And minus y plus y will give you 0, and e to the power 0 is 1. So this would be 1. Now you cross multiply. 1 times e to the 2y minus 1, and x times e to the 2y plus 1. Now, this is where you got to rearrange it in such a way that it makes your life easier. So what you want to do, you want to take minus 1 to the left, it becomes plus 1. Take minus 1 to the left, it becomes plus 1. And take xe to the 2y to the right, it becomes minus xe to the 2y. You got to swap them in a way that makes your life easy. So the left side will have 1 plus x, and the right side will have e to the 2y minus xe to the 2y. Now what do you do next? You factorize. There's e to the 2y on this first one, e to the 2y there. So e to the 2y comes out of bracket, and you're left with 1 minus x, because this is like times 1. So you're left with 1 minus x there. Now you want to get e to the 2y on its own, because your aim is to make y the subject. So you divide by 1 plus x. So you divide by 1 minus x. So you have 1 plus x divided by 1 minus x is equals to e to the 2y. Now, because we got e, we have to take natural logs. So if you put ln, I've put it in pink, take ln on the left side and ln on the right side. And we use power to the front law. 2y can come to the front. So it becomes 2y ln e is equals to ln 1 plus x over 1 minus x. Ln of e is 1. You can put that in your calculator. Ln e, you get 1. So you cross that out. So you're left with 2y is equals to ln 1 plus x or 1 minus x. It's times 2. It's opposite of times 2 is divided by 2 or multiply by a half. So y equals to a half ln 1 plus x or 1 minus x. And for this function not to be 0, if you look at 1 plus x over 1 minus x, you cannot divide by 0. So 1 minus x, for it to be 0, 1 would be equals to x, or x is equals to 1. And you can say that k is equals to 1, or you can have between minus 1 less than x less than 1. That's what you define for the value for k there. Part B, hence or otherwise solve the equation. Hence means use your answer from before, or otherwise use any other method you want. Solve the equation. Usually it's just to go with what you've done before, if it can make it easier for you. So we want to solve 2x is equals to dan of ln square root of 2 minus 3x. So what you want to do is you multiply by the inverse dan for each side. So inverse dan times 2x. So you multiply inverse dan times 2x, and you multiply on the right inverse dan times that. So you multiply by inverse dan on both sides to make it fair. So you end up with inverse dan on the dan 2x. The inverse dan and the dan in the right side will cancel each other. So you just end up with ln square root of 2 minus 3x. Now you will say, from what you had done before in part A, that's where you're using the hence, and they're giving you the answer in it. So even if you didn't get it, you can use that answer which was given to you in part A. That's something you got to remember in A-level questions. You may not have proved this in part A, but you can still come and do part B using that answer. We know that tan inverse of x is equals to half ln of 1 plus x over 1 minus x. But instead of x, they're having but 2x. You see that? Instead of x, they're having but 2x. So what do? We replace our x there with 2x to make it double, because x is double. So we will have tan inverse of 2x is equals to half ln 1 plus 2x over 1 minus 2x. And now we know that tan inverse of 2x is this. We would replace that tan inverse of 2x there using this expression. So now we have, instead of tan inverse of 2x, we'll replace it with this because we got that from there. So that's, remember that swap. And then we have half ln 1 plus 2x or 1 minus 2x equals to ln square root of 2 minus 3x. So what we're going to do, use of the power law of logs to obtain an equation with logs removed. Now we're going to, you notice that we can take half to the front, to the power law of logs. So half can go there. So it becomes ln of 1 plus 2x to the half divided by 1 minus 2x equals to ln. Now we can remove the ln because there's ln on the left, ln on the right. So we can remove the ln. So when you remove the ln, you end up with 1 plus 2x to the power half is equals to that. Now, if you square both sides, this half would cancel on the left and the square root sign will cancel on the right. So you go 1 over 1 plus 2x over 1 minus 2x equals to 2 minus 3x. And then you cross multiply, you get that expression. And then you expand these double brackets, you get the next one. And you put everything to the left side. You take everything to the left, side, and then you would get this quadratic 6x squared minus 9x plus 1. And how do you solve a quadratic? You use your calculator. A is 6, B is minus 9, C is 1. Or you can use the quadratic formula. And you have two answers. You get 9 minus root 57 over 12. And you will get 9 plus root 57 over 12. And you have to reject this one. So one of the answers is rejected, and you accept this answer. So in the exams, it's very important to tell them that you've rejected an answer and tell them the one that you've accepted. Sometimes they would accept it by omission. If you didn't write this one at all and you only write this answer, they will say you've rejected the other one by omission, by not writing it. But sometimes you can write it and state it that it is rejected. So this is the examiner's report for this question number 1. Things to make note of. Most of the students were struggling to make e to the 2y the subject. So when you had e to the 2y in that expression, that was something that those who did make e to the 2y usually did so correctly, although if you did not convert the result, that was one of the problems there. And a significant number neglected to state the value of k. It's very important in A-level questions. Those last bit, which they say state the value, or don't neglect it because you get marks for that. So a significant number, lots of A-level students neglected to state that last value, that last thing, the value of k. So everything you need to state it so that you can get the mark. Some students use differentiation and followed by integration, but they could not get full credit because they had lots of mistakes. So the method you use is very important sometimes to make it easier. For part B, it was more successful for most students with occasional slips. But when it came to solving this quadratic, the quadratic was almost always solved correctly. So most people were solving the quadratics correctly. But where did they fail? Many failed to reject the ineligible solution. When you solve the quadratic, you had two answers. So you always have to decide whether those two answers would work. And one of them was ineligible. So you had to say which one. Despite being asked about the range of validity of tan x in part A. And in presentation, students were confusing between tan x and tan x. So they were mixing between those two. So that's the examiner's report for question number 1.